Okay, good evening. Welcome to the live session for week 2 of characterization of construction materials. So, as you know, how this live session will proceed is based on the previous week content. So, since we are already in week 4, so today it will be a mix of week 2 and week 3, mostly on week 2, but we'll also have some content from week 3 as well. So, what did we learn in week 2? It was mostly calorimetry, and in week 3, we also looked into the basics of X ray diffraction, right? So, both of these are characterization techniques which we widely use in the case of characterizing construction materials. Okay, so without further ado, let me share the screen and please let me know if the screen is visible. Okay. Okay, I think my screen is visible. Can someone confirm? Am I audible and is the screen visible for both of you?
Yes, ma'am.
Okay, thank you. Thank you so much. So, yeah, welcome again. So, this is like an interactive session and also a warm up session. Consider this as a learning session. So, don't be hesitant to express your opinion in the chat box. So, how the session will go? We'll project the question in the screen. I'll also read out the question for you. And then I expect you to put the answer in the chat box. Okay. After giving a few seconds or a minute, I'll tell the answer, and if it requires further explanation, we'll explain it also. Okay. So, first, let's move to the first question, which is also based on the week 2 content. So, initially, we'll have some basic questions, and as we proceed, we'll have in detail. Okay. So, yeah, the first question is this: calorimetry can be used to study the process in which there is a change in dash. So, the question is about calorimetry. It is used to study the process in which there is a change in weight, enthalpy, volume, length. I hope the question is pretty clear. Whenever there is a change in dash or wherever there is a change in dash, calorimetry can be used. What is that dash? Is it weight? Is it enthalpy? Is it volume? Or is it length? I'm just waiting to see some answers in the chat box. Again, let me tell you, it's okay if you're wrong. Who has unmuted? Javed, do you want to say something?
No, ma'am.
Okay, yeah. Okay, so I again go to the first question for today's session. It's a very basic question. To use calorimetry, what has to be the what should be there in the process? As in, what change has to be there? Is it weight? Is it enthalpy? Is it volume? Or is it length? Yes, Vinu has commented that it is enthalpy. Okay, I think I have given enough time for you guys to respond. That's all the answer I'm getting. Do any one of you have a change of opinion? Okay, Smita also goes with enthalpy. Yes, as rightly said by both of them. Okay, Mehana also goes with enthalpy. Okay, so I guess I need to provide more time for you. Uh, no problem. So the correct answer is B, which is enthalpy. So calorimetry can be used when there's a change in enthalpy, that is an energy difference. Like in the case of cement hydration, there's it is an what kind of a reaction? Is it exothermic or endothermic? Cement hydration. What kind of a reaction is that? Is it exothermic or endothermic? Endothermic means it absorbs heat, exothermic means it liberates heat. I'm just waiting. Someone please put in the chat box. What kind of a reaction is cement hydration? Yeah. So it's an exothermic reaction. So it liberates heat. So obviously there is an energy difference, there's an enthalpy difference. So calorimetry can be used to study the process such as cement hydration. Okay, so not a part of this question, but what can be used to study the process if there is a change in weight, mass gain or mass loss? If anybody knows, it'll be nice. Like if they can put it in the chat box. So based on the mass gain or mass loss, a sample can be analyzed or a reaction can be analyzed. What kind of technique is used if there is a change in mass? So I'll give one more clue. So if there is a change in temperature, if there is an increase in temperature, the mass changes. It can be either a mass gain or a mass loss. And by analyzing at what temperature, what mass change occurred, we can get some information about the sample. So that is also a characterization technique. What is that technique which helps in getting the data of a sample based on the mass change of the material when there is a temperature change? Yes. So as Vinu rightly told, you can see it is TGA. What is TGA? Thermogravimetric analysis. So based on temperature, gravimetry means mass change or weight change. So based on the mass change or weight change during the change in temperature, we can analyze the sample. So that is thermogravimetric analysis. So if the option is A, it will be TGA. Okay. So here calorimetry if there is an enthalpy change. Okay. So let's move to the next question here. Again, it's about calorimetry. Calorimetry is a measurement of A and B. What are A and B? So what does calorimetry measure? Does it measure mass and heat? Option A. Or option B, it is color and mass. Or option C, heat and heat rate. Or option D, temperature and density. So there are two things which can be measured using calorimetry, A and B. What is A and B? It measures the temperature, density, heat rate, color, mass, heat. Okay, Smita goes with D, temperature and density. Okay, let me wait for a few more seconds so that others also can respond. So do everyone agree with Smita here, or is there any change of opinion? Okay, Vinu goes with C. Okay, so now we have two opinions. One goes with C and one goes with D. Okay, so what about others? Javed, what do you think? Or Mehna, do you go with either C or D, or do you have a different opinion like A or B? I hope I have given enough time. Anyone else? Okay. So as I'm not getting any further response, so is it C or is it D? Okay. So the correct answer is option C, as rightly told by Vinu. So this is a snippet from the slides, which is already shared with you. So here, if you see, the first line itself says that calorimetry is a measurement of heat and heat production rate. That is exactly why we can use calorimetry in analyzing or in studying cement hydration, right? Because in the previous question, when I asked whether cement hydration is an exothermic or an endothermic reaction, we got the reply that it is an exothermic reaction, which means that it produces heat. So, by analyzing how much heat is produced or what is the rate at which the heat is produced, we can analyze the sample or we can get to know more about the sample. Okay, so it's the measurement of heat and heat rate. Sorry, it's not temperature and density. Yes, temperature is measured in the case of adiabatic, but it's not density also. So the correct answer goes with heat and heat rate. Finally, we get to know about heat and heat rate. Okay, let's move to the next question here. So this is a true or false question. During the induction period of cement hydration, heat of hydration rate becomes zero. State true or false. During the induction period of cement hydration, heat of hydration rate becomes zero. Okay, let's move to the answer now. So the correct answer is true. As you can see here, there is no heat rate, right, in the case of an induction period. So the correct answer is true. Okay, let's move to the next question. I think this is more interesting. Yes, thank you, Javed. Yeah, let's move to the next question. Arrange the Box compounds. So Box compounds are C3A, C2S, C3A, and C4A5. So arrange these Box compounds in the decreasing order of their coefficient of heat of hydration at 28 days. So read the question carefully. What I'm asking about is about the coefficient of heat of hydration at 28 days. So option A states C3A has higher and least is C4AF. Option D states C3A has higher and C2S has least. Option B says C3S has higher, C4AF has least. Option C says C4AF has higher and C3S has least. So arrange the box compounds in the decreasing order. Okay, that was a very good guess. I mean, if it's not a guess, also it's good because unfortunately, the sorry, this is not correct answer. Is not A. Correct answer is D itself. Okay, let me change it here. 1 second. It's taken from this table, which shows about the coefficient of heat of hydration at particular days, like 3 days, 7 day, 28 day. Since we have a 28 importance to 28 day, I try to include that 28 day coefficient of heat of hydration in the question. So C3 A has the highest coefficient of heat of hydration, and then C4AF, then C, then C2S. Okay, let's move to the next question. Choose the correct statements regarding cement hydration from below. So the first statement says C2S reacts with water to form calcium silicate hydrate and portlandite. Option B, ettringite reacts with gypsum to form monosulfate. Option C, C3A reacts with gypsum to form ettringite. Option D, ettringite reacts with C3A to form monosulfate. Okay. So Javed says option A is correct. Okay. So which means that B, C, D are wrong. A, just A is correct. Okay. So what about others? And for the future assignments and also for the sake of the final exam, if you see statements, most probably it will be a multiple correct answer question. So it can be either A and B, or A and D, or ACD, like that. Maybe ABCD also. So read the question carefully again. It says correct statements. So there's a high chance, I'm not telling there's always, but there's a high chance that more than one answer is correct, one option is correct. Okay, let me wait for a few more seconds. That's all. Anyone else wants to comment? So this is a very basic question, right? It's about cement hydration. So first statement says that C2S plus H2O gives CSH and CH. And option B is ettringite reacts with gypsum to form monosulfate. C states C3A reacts with gypsum to form ettringite. And also D states ettringite reacts with C3A to form monosulfate. Okay. Vinu goes with D. Okay. So let me wait for a few more seconds. Okay. So I think that's all the response I'm getting. So the correct answers are, sorry, yeah, sorry, there is no E here. So that's not the correct option. So yeah, A is anyway correct because A, C2S reacts with water to form calcium silicate hydrate and portlandite. So C is anyways correct. Second thing states that ettringite reacts with gypsum to form monosulfate is a wrong statement. Yeah, C. C3A reacts with gypsum to form ettringite is a correct answer. So it is option C. And ettringite reacts with C3A further to form monosulfate. So that is also a correct option. So the correct answers are A, C, and D. Okay. Okay, let's move to the next question here. It's also related to calorimetry now. Isothermal calorimeters measure dash. So this seems to be a very easy question, but read carefully. Isothermal calorimeters measure dash temperature, heat, or pressure. This is a pretty easy question. Isothermal calorimeters measure temperature or heat or pressure. Option A is temperature, B is heat, C is pressure. I'm waiting for some response in the chat box. Okay, Vinu goes with A, temperature. Anyone else? That's all. Only one response. Please respond in the chat box or please unmute yourself and share your answer. It's okay even if you're wrong. Okay. So without wasting much time, let me go to the next. Let me go to the answer. So the correct answer is iso. Again, there's some issue here. Isothermal calorimeters. Actually, it keeps the temperature constant. So it measures the heat. Okay, isothermal calorimeters, it keeps the temperature constant and it measures the heat. So the correct answer is B. Okay, let's move to the next question. I hope at least this one, the answer provided will be correct. So choose the correct statements regarding the reference samples used in the isothermal calorimeter. Okay, so in the case of isothermal calorimeter, we need a reference sample and our own sample which we need to analyze. Okay, so what has to be the reference sample type for it to be used as a reference against the sample which we need to analyze. So option A states that the reference sample should not produce any heat. Option B, the reference sample should have a higher heat capacity than that of the sample. Option C, reference sample should have the same weight as that of the sample. Option D, reference sample should have a lower heat capacity than that of the sample. Then option E, the reference sample should have the same thermal mass as that of the sample. So these are the five options you have. Shouldn't produce any heat, should have a higher capacity than the sample, should have the same weight as that of the sample, should have a lower heat capacity than the sample, or option E is have the same thermal mass as that of the sample. So choose the correct statements regarding the reference samples. I'll give a minute for this. Read carefully and please answer. Okay. Options A, C, and E. Okay, thanks, Vinu. Let's wait for some more time. Okay, Smita goes with B, D, and C. B is higher. D is Smita. B and D are self contradictory. We want to revisit the answer you provided because B and D are self contradicting. It says one says higher heat capacity, the other one says lower heat capacity, and you say both are true. So just read the options again. And also, she also goes with C. That is, it should have the same weight as that of the sample. Okay. We'll give a few more seconds. Okay, I guess that's all the response I'm getting. Okay, so the correct answers are only A and E. Unfortunately, C is not there. We can even use a sample with higher mass as a reference sample or a lower mass as reference sample. It's not a problem. The only thing is that you should have the same thermal mass as that of the sample. And what is thermal mass? We'll come to that. And also, the reference sample should not produce any heat. Then only we can measure the heat produced by our sample to be analyzed and used for the uh, and can be captured by the isothermal calorimetry. Okay, I hope that is clear. Actually, the reference sample should have the same heat capacity as that of the sample, and it's not the same. It's not necessary that it should have a same weight as that of the sample. Okay, so the correct answers are A and E. Now, E states that the reference sample should have the same thermal mass. So, the next question is related to thermal mass. Calculate the thermal mass of a 15 gram of sample with a specific heat capacity of zero point 0.5 joule per gram Kelvin. So read the question carefully. How much sample we have taken? We have taken 15 gram of sample and the specific heat capacity of the sample is zero point 0.5 joule per gram Kelvin. So what will be the thermal mass of this sample, of this 15 gram of sample? Okay. Yeah. Binu goes with 7.5. Okay. 7.5 joule per Kelvin. Okay. Javed also goes with the same. Thanks both of you for the response. What about others? Question is pretty simple. 15 gram of sample which has a specific heat capacity of zero point 0.5 joule per gram Kelvin and calculate the thermal mass of the sample. Shall we move to the correct answer or should I wait for a few more seconds? Calculate the thermal mass of 15 gram of sample with a specific heat capacity of zero point 0.5 joule per gram Kelvin. Again, the sample mass is 15 and that sample has a specific heat capacity of zero point 0.5 joule per gram Kelvin. So calculate its thermal mass. Okay, let's move to the correct answer. The correct answer is A. So what is the thermal mass? It is the product of mass of the sample and its specific heat capacity. Okay, so here the mass is 15, specific heat capacity is zero point 0.5 joule per gram Kelvin. Multiply both, you will get 7.5 joule per Kelvin. Okay, so the correct answer is A. So thank you guys for the response. Okay, let's move to the next question here. Now, adiabatic calorimeters measure dash temperature, heat, or pressure. Okay, so Vinu and Prasad goes with B, which is heat. Okay, let me wait for a few more seconds. No further response. Okay, so the correct answer is A. Okay, Smita told it's A. Because in the case of isothermal calorimetry, it means that the temperature is kept a constant. So, what it measures heat. In the case of adiabatic calorimeter, the opposite occurs. That means it ensures that there is no heat change occurs. So, as a result, whenever there is a temperature increase or temperature decrease, that is measured. Okay. In the case of isothermal calorimetry, heat is measured, and in the case of adiabatic calorimetry, it is the temperature which is being measured. Okay. Let's move to the next question. Okay. So this is something which you have to work out. For an isothermal calorimeter, baseline is 2 volt. That is when there is no sample kept, it shows a 2 volt. Reaction of 10 gram of sample for 7 days resulted in 220 volt. Okay. If the calibration coefficient of that particular instrument is zero point 0.5, then calculate the thermal power and specific thermal power. So baseline is 2 volt. After 7 days of 10 gram of sample, it resulted in 220 volt. Then if the calibration coefficient is zero point 0.5, what is the thermal power and specific thermal power? So I'll give some extra time for this question because you have to work it out. Please do work it out and let me know what is your answer in the chat box.
Ma'am, for the problems, if you explain with the equations, it will be more useful.
Okay, that I'll do. But if I give the equation right away, it is just a matter of you putting the values there.
Yeah, do after discussion.
I'll. So in there was only one equation which was one problem before, right? That was about thermal mass. So
Ah,
that I showed the PPT slide itself. That is thermal mass is the product of mass of the sample and
both
its specific heat
samples.
capacity. So
Hmm.
that was clear, I suppose. For this, I will discuss with the equation.
Okay.
No response from you guys? Come on, at least one should do. So take baseline as U naught and resulting voltage after a particular number of days. Here in the case 7 days as U. Calibration coefficient is epsilon, which is zero point 0.5 here. Any response? I mean, some response. Okay. Let me move to the next slide, which has an answer. Sorry, whether the theory part related to the problems has been discussed, I think. Okay, Prasad. So I have explained how this live session particularly goes. So we were asked to discuss the previous assignment questions and also the questions related to the theory which was covered by the professor. Okay, so I have a few questions which is related to the content which was already explained by the professor. So here the content was pretty straightforward. So through the questions we are explaining the concepts. So but in particular, in this case it's about isothermal calorimeter, and there was a particular problem of calculating the thermal power and the specific thermal power. So the theory is already explained by the professor, and through the questions, we'll again discuss the necessary items. We will not be discussing the theory again in the live sessions. So I hope that is clear. So through the questions, whatever comes through the questions, we'll discuss and go. All the most of the major problems will be discussed.
Okay, ma'am. Okay, thank you. My concern is okay. Let me introduce myself. Myself, Prasad Bishetti.
Yeah. Hi, Prasad.
So this is the first class I am joining
Yeah.
regarding this discussion around six
Okay.
o'clock to 8 o'clock. So whatever the assignments we get weekly.
Mm.
So right now the week third assignment is running off,
Yeah.
and we need to submit it by Wednesday.
Yeah.
So whatever the problems we are going to submit by Wednesday,
Mm.
regarding that, the discussion is going to happen in these
No.
classes or else
No.
after submission.
After submission, if at all you have certain doubts regarding particular assignment questions,
Okay.
you can ask it in the discussion group,
Okay. Okay.
or
Fine.
you can ask it during the live sessions. But that is not so much encouraged because
No,
we'll
no.
have
That
around.
is not particularly about the question what they have posed.
Now,
Means general discussion we can have.
general discussion we can have. Yes,
Yeah. That's right, ma'am.
that is
Okay.
there.
Thank you. Okay. Fine.
Okay.
Thank you.
So, okay, regarding your question, so yesterday, another TA she discussed about the week two and week three content. So
Okay.
today I'll be mostly focusing on week two and week three, mostly
Fine.
focusing on week two and some questions from week three.
Fine.
And the coming live session on Friday, another TA will discuss about week three and week four.
Okay, ma'am. Okay.
Okay, and
Okay.
next week onwards we will be discussing week four, and in Friday there will be week five. I hope, I
Okay.
mean, I hope you got it. So Friday, Monday, Tuesday. You can keep it like that.
Okay. Okay. Because initially we didn't came to know about these sessions also. So
Ah, ha, ha.
later, that's the problem. Okay.
Okay.
No issue,
So
ma'am.
here,
Thank you.
this is how we have planned it. If you have some suggestions, they are welcome. But this is how we have planned as of now. We'll have the questions and we'll discuss the answers.
Friday, Tuesday, as well as
Friday, Monday, Tuesday.
Friday. Okay. Monday, Tuesday, Friday.
Same timing, 6 to
Okay.
8. It will not go up to 8. It will be
Okay.
there 1.5 hours.
Okay, ma'am. Thank you.
Okay. Sure. So regarding the question here, the baseline, if you see the portion here, the thermal power is epsilon into U minus U naught, where U is the signal from the sample after a particular number of days. So here in the case, after 7 days, it is 220. U naught is the baseline. That is when there is no heat production or when there is no sample being kept inside the isothermal calorimetry, the baseline is 2 volt. So we have to subtract. That is 220 minus 2 volt, that is 218, into epsilon. Epsilon means coefficient of the instrument, calibration coefficient of the instrument, that is zero point 0.5. So the answer will be 109 volt for the thermal power. And what is specific thermal power? That is also given in this slide. It is thermal power divided by the mass of the binder. So that is why here the 10 gram is given. So this thermal power 109 volt divided by the mass of the binder is 10. So 109 by 10, that is 10.9 volt per gram. So I hope this is clear. So thermal power is calibration coefficient into U minus U naught, where U um, is the volt or the output at a particular number of days at a particular duration, and U naught is the baseline whenever there is no heat production. And the specific thermal power is the thermal power divided by the mass of the sample you kept inside the isothermal calorimeter. So here the correct answer becomes A, that is 109 volt as thermal power, and specific thermal power is 10.9 volt per gram. Okay, let's move to the next question. The Tian equation is used in the analysis of calorimetry results of rapid processes, considering the time lag of the instrument. State true or false. So it's just a true or false question. Obviously, it's not like when you keep the sample inside, immediately the instrument will start producing the result, or there's some time lag. We have to consider that time lag also whenever we are trying to get results of some rapid processes. So the equation which is used in the analysis of calorimetry of rapid processes, considering the time lag of the instrument, is Tian equation. State true or false. I thought it's a pretty easy question. Okay. So the correct answer is true. So the time constant, that is this is a Tian equation. So this equation is used to correct the rapid processes for the time lag of an instrument. It's used in the case of rapid processes, and whenever there's a time lag of an instrument, we have to take that into account. And taking that into account is a Tian equation. Okay. So let's move to the next question. Compared to the adiabatic calorimeter, the sample size allowable in isothermal calorimeter is lesser or higher. So this is one another characteristic of isothermal calorimeter. This is about the sample size. So sample size in isothermal calorimeter is lesser than the sample size in the adiabatic calorimeter, or it is higher than the adiabatic calorimeter. Okay, Prasad goes with lesser. Is there anyone else? What about others? Okay, we have five people here. Okay, Smita also goes with A, which is lesser. So compared to adiabatic calorimeter, the sample size allowable in isothermal calorimeter is lesser or higher. That's the question. Minu also goes with lesser. Okay, I think it was a pretty easy question and straightforward question. Yes, the correct answer is lesser. We can only use a lesser amount of isothermal of sample in the isothermal calorimeter compared to that in the adiabatic calorimeter. So that is one advantage of adiabatic calorimeter. We can use higher sample size, and which is also an advantage of isothermal calorimeter. We need to keep only a lesser amount of sample in the case of an isothermal calorimeter. Okay, let's move to the next question. Heat energy is kept a constant in this type of calorimeter. In the case of cement hydration, heat is liberated and temperature increases. This increase in temperature will influence the hydration rate and thereby the heat of hydration calculation. So this is just a few statements. Which type of calorimeter is referred to in this paragraph? So read the paragraph. So it says that in this type of calorimeter, heat energy is kept a constant. In case of cement hydration, heat is liberated and the temperature increases, and this increase in temperature will influence the hydration rate and thereby the heat of hydration calculation. Which type of calorimeter is referred to in this paragraph? Vinu goes with isothermal, Prasad goes with adiabatic. Okay, I think you need not get worried about this three sentences. The answer is there in the first sentence itself. The correct answer is adiabatic. Okay, so let me tell it again and again. Isothermal means sorry, isothermal means in that particular calorimeter temperature. Thermal you can relate it with temperature. So isothermal means that temperature is kept a constant. So, as a contrary to that, in adiabatic, heat energy is kept a constant. Okay, anything with isothermal, uh, like that. It means that it is kept a constant. So, isothermal means temperature is kept a constant. So, in adiabatic, heat energy is kept a constant. So, the correct answer is adiabatic. Okay, let's move to the next one. Mixing energy influences the hydration. Say it true or false. It's just a blunt statement or it is just a straightforward statement. If you mix cement paste with hand and if you mix the cement paste in an equipment like using a mixer, does both of these influence hydration? Because obviously the energy is different in both the cases. The energy is lesser in the case of hand mixing, and if it is using a mixer, energy is more, right? So mixing energy influences the hydration. It's true or false? Okay. Binu and Prasad says true. Okay. Does anyone else wants to answer this question? Yeah. So the correct answer is true. So yeah, it clearly influences the hydration. So if you see this figure, so this line and this dotted line, both these lines are of the same mix, but one is hand mixed and the other one is machine mixed or with the help of a mixer. So clearly both the lines are different and it clearly influences the hydration. Here the heat of hydration is much higher than that of the hand mixed one, and it's much earlier also. Okay, let's move to the next question. As the temperature increases, the isothermal calorimetry curve shift to right, shift to the left, or stays unchanged. So here, temperature is about the testing temperature or the analysis temperature. So suppose the temperature is kept as constant as 50 degrees Celsius. And in the next case, temperature is kept as a constant as 75 degrees Celsius. Same mix. So in this case, will there be a change in the calorimetry curve is a question. Option C says that there won't be any change. Okay, Prasad asks higher energy, more heat. Yes, that's majorly because we mix. There's a uniform blend which is happening if it is a higher energy, and because of that, the heat energy also given to the sample is also higher, As a result, there will be a more efficient hydration happening at an earlier stage itself than when we mix with the hand. Okay. So here the question is, temperature increases, that means the testing temperature increases, the isothermal calorimetry curve shifts to the right, shifts to the left, or stays unchanged. So suppose in the first case we use one mix which is tested at 50 degrees Celsius, and in the second case the same mix is tested at a 75 degrees Celsius. Will there be a change in the isothermal calorimetry curve? Option says that yes, there will be a change and the curve shifts to right. And option C says that yes, there is a change but the curve shifts to the left. Option C says that there's no change. Excuse me. Okay, goes with C. That is, we know goes with C. That is stays unchanged. Any other response from anyone else? Okay. So the correct answer is it's shift to the left. So obviously, when the temperature increases, the rate of reaction increases and the heat of hydration also increases. So as the testing temperature increases, the curve shifts to the left. So this particular curve is at 5 degrees Celsius. Try to, yeah. Particular curve is at 5 degrees Celsius. When it is became 20 degree, it shifts to the left and the peak also is higher. 30 degree, the peak is higher and it shifted to the left. Again, 40 degree also it shifted slightly to the left. So the correct answer, yes, that the temperature increase influences the curve from isothermal calorimetry, and what happens as the temperature increases, the curve shifts to the left. Okay, let's move to the next question. Which of the following can be studied using calorimetry? So this is a very general question. So there are three reactions or three processes given in the option. First one is reactivity of SEMs. Second one is interactions between cement and admixtures. Third is evolution of pore structures. So which of this or which among these or which of these can be studied using calorimetry? Option A is SEM is supplementary cementitious materials such as fly ash, metakaolin, silica fume, etc. So their reactivity can be studied is the first option. Second option says that the interaction between cement and the admixtures can be studied. Option C states evolution of pore structures. Okay, Prasad goes with A, that is reactivity of SEMs. Anyone else? That's all. Okay, let's move to the correct answer. The correct answers are A and yeah, Prasad says even B is correct. Yes, both A and B are correct because See, in the case of evolution of pore structures, we cannot determine because there is no enthalpy change happening. In both other cases, in the reactivity of SEMs or when an admixture reacts with the cement. For example, there are certain admixtures which curb the initial hydration. It slows down the initial hydration, like accelerate. I mean, retarders, or some increase the rate of initial hydration, such as accelerators. So, in order to know their efficiency, or in order to know about the heat release and the rate of heat release, we can use calorimetry. Even in the case of first option, reactivity of SEMs, the reactivity of SEM addition can be measured using the calorimetry because they also involve an enthalpy change. When there is an SEM addition, it can either cause, sometimes it causes an increased heat release, or it shows the same heat release but a later stage. So all these kind of responses can be captured using calorimetry. But in the case of evolution of pore structures, it cannot be captured because there is no enthalpy change occurring, and because of that particular reason we cannot capture using calorimetry. So correct answers are A and B. Okay, let's move to the next question. Okay, this is quite a lengthy question, so let's give due amount of time to this one. Hydration of a Portland cement was monitored using isothermal calorimetry. Pretty clear. Then, when the cumulative heat release during the hydration of this particular Portland cement was measured as 200 kilojoule, that is a cumulative heat release. Calculate the degree of hydration of Portland cement based on the following information. So here the composition of the cement is given. C3S is 60 percentage, C2S is 20, sorry, 25 percentage, C3A is 8 percentage, C4AF is 7 percentage. So this is the composition of the particular Portland cement. And the enthalpies are also given. Enthalpies of C3S, C2S, C3A and C4AF are also given in the last line. Given all these data, that is the composition and their particular enthalpies, what is the degree of hydration, or alpha is the question. Okay, Javed goes with option B, that is point 0.4. Let's discuss this question in detail, but for that, let's give a minute or two for others to respond. Only Javed has responded so far, I guess.
Ma'am, the same problem has been discussed in the yesterday live session.
Of course, yes, because we are asked to discuss the previous assignment questions also. It's not the same people who are attending all these three sessions, right? So we are morally obliged to discuss more questions in all the sessions.
I'm sorry, ma'am, I have been sitting in the three classes, that's why.
Oh, okay, okay, okay. Don't worry, we'll be having a mixed questions.
Okay, ma'am.
See, so you could sit for all the three classes, well and good, but there will be some people who might miss one or two classes, right? So, considering them, we'll have a mixture of questions from both the classes.
Ma'am, you are not audible.
I'm not audible, but my mic is on, still on.
Yes, ma'am, audible.
Okay. Some issue with the person who just told I'm not audible. Maybe you can rejoin and see. Okay. Mehna, then you might know the correct answer, no?
Yes, ma'am.
Okay. then you might find the following some of the questions also repeating. Sorry for that.
Yes, ma'am. That's why I asked.
Okay. I just think that there will be some people who might not have attended the previous class, so that's why.
Okay, ma'am.
Okay, so let's move to the correct answer. So this is a snippet from the slide itself. So the total heat release is A into C3S plus B into C2S, C into C3A, D into C4A. So it just means that the percentage of C3S into the enthalpy, particular enthalpy, plus percentage of C2S into the enthalpy, plus the enthalpy of C3A plus into percentage of that, plus 418, that is the enthalpy of C4AF into the percentage of C4AF in the cement. So the percentage of the Bohr compound into their corresponding enthalpy. Sum of all that will give you the HT, or the heat release. That is 496.48 kilojoules. So the alpha is the cumulative heat release divided by the heat release which we got or obtained through this equation. That is 200 by 496.48, that is zero point 0.4. Okay, so the correct answer is zero point 0.4. Okay, let's move to the next question. So, which of the following cement composition will generate more heat during early hydration? So, the options are less C3S, less C2S, and more C3A, or less C3S, more C2S, and less C3A. That is just the opposite of the option B, option A. Then option C, more C3S, less C2S, and more C3A. And the last option, less C3S, less C2S, and less C3A. So here the question is about the early hydration heat release. Okay, Javed goes with option C, C3S, C3A higher and less of C2S. Okay, anyone else? Javed C and no one else? Okay, let's move to the correct answer. So the correct answer is C, as rightly told by Javed. So here, in initial hydration, let's say 3-day hydration, C3A and C3S has very high coefficient of heat release. That is 887 and 243. Numbers are not quite important here, but C3S and C3A contribute to the initial heat release or the initial strength and stiffening also. In the case of C3A, stiffening also, and in the case of C3S, initial strength also. So, as the C3S and C3A content are higher, that particular mix will be generating more and more heat. So, here in the question, both C3S and C3A content are higher in the case of option C. So, the correct answer is option C. Okay, let's move to the next question. In an isothermal calorimeter, the reference sample should be selected so that it is having the same dash as that of the actual sample. So, this question was discussed in a different way a few questions before. Even in the same live session, we have discussed this concept. So, in an isothermal calorimeter, we use a reference sample and a sample to analyze, which we have to analyze. So, both of them should have same density or same heat capacity or same heat flow or same weight. Okay. Vinu goes with option B. Thanks, Vinu, for responding. Anyone else? Okay, I guess let's move to the correct answer. So the correct answer is option B, that is heat capacity. Both have to be same. The heat capacity of the reference and the heat capacity of the sample have to be same for the for it to be used as a reference sample. Okay, let's move to the next one. So it's a massive following question. Adiabatic calorimeter, semi-adiabatic, and isothermal are in the first column, and the second column is heat loss is not constant, constant temperature, no heat loss. So you can put the answer in the chat box like A2, B1, C3, or say A1, B2, C3, like that. I'll give time for you to type, but please do respond in the chat box. Otherwise, it will just become very monotonous. I'll be the only one who is speaking, and I'll not see any responses also. Option, the adiabatic calorimeter, semi-adiabatic, and isothermal are the options in the options in column first column, and in the second column it is heat loss is not constant, constant temperature, and no heat loss. Okay, we know type that A3, B1, and C2. Okay, let me give a few more seconds for others if they are typing. Is there anyone else typing? So this is basically the crux of week 2 content. Got it. Okay. The smart way of answering. Okay, thanks Javed for responding. Okay, so let's move to the correct answer. A3, B1, and C2. Yes, Vinu is correct and hence Javed is correct as well. So, adiabatic calorimeter, there is no heat loss. That's what we were telling. The heat is kept as a constant in adiabatic. In the case of semi adiabatic, that's not the case. Heat loss is not a constant, there is a heat loss. And the case of isothermal, which means that temperature is kept a constant. So it's a constant temperature thing. So A3, B1, and C2. Okay, let's move to the next question. Which of the following case will increase the rate of heat release on early hydration of cement? Grinding finer, increasing the temperature, decreasing the water to cement ratio, or none of the cases. Which of the following case or cases will increase the rate of heat release on early hydration of cement? Reducing the fineness, that is by grinding it finer and finer. Sorry, increasing the fineness by grinding it finer and finer, increasing the temperature, or decreasing the water to cement ratio. Minu goes with A and B. Okay, let's move to the correct answer. So here the correct answers are A, B, and even C. So in the case of grinding it finer, we know that there is more surface area present for hydration. As a result of this, there will be an increased rate of hydration and increased hydration in the as a whole. In the case of grinding it finer and finer. In the case of increasing temperature also, here we saw even before we saw that as the temperature is increasing, the curve shifts towards the left, and also there is an increase in the rate of heat release. And in the case of using a lesser water to cement ratio, this is the case, it moves towards the left and there is an increase in the rate of early hydration. Okay, so let's move to the next question. It's a true or false question and it's from the week 3 content. X-ray diffraction pattern of amorphous material will not have a sharp maxima peaks. True or false? Okay, we know goes with A. Anyone else? This is a pretty easy question. If you have seen an X-ray diffractogram of a crystalline material and an amorphous material, it will have its own characteristic differences. The sharp maxima or or the sharp peaks are characteristics of one type of material. So here the question or the statement states that the X-ray diffraction pattern of amorphous material will not have sharp maxima. Okay, it's a very straightforward question. So the correct answer is A. Correct answer is A. It will not have sharp maxima. It will have a curved structure or it will have a hump in the case of amorphous material. See, in the case of crystalline material, it will have sharp maxima peaks. If you just see the difference, this is a crystalline material and this is an amorphous material. In the case of crystalline, we can see sharp peaks. In the case of amorphous material or liquid material, we can see humps instead of sharp peaks. Okay, let's move to the next question. What is the minimum interplanar spacing required for Bragg's diffraction? So this is also from X-ray diffraction that is in the week 3 content. We're just starting the week 3 content. It will more discussed in detail in the next live session, in Friday's live session. So what is the minimum interplanar spacing required for Bragg's diffraction is the question. So Javed says D. So here we have to use a Bragg's equation, n lambda equal to 2d sine theta. Using that equation, you have to find the answer for this. What is the minimum interplanar spacing or d dash required for Bragg's diffraction? Okay, let's discuss the answer. So here we all know the Bragg's law, that is n lambda is equal to 2d sine theta, and from this, when the order of reaction is 1, nth order of reaction, instead of that for the first order of reaction, it is lambda equal to 2d sine theta. So d will be lambda by 2 sine theta, right? Or in this case, if you see, sine theta is equal to n lambda by 2d, and always sine theta is less than 1. So for the smallest value for n equal to 1, lambda by 2d has to be less than 1, which means that d has to be greater than lambda by 2. Okay, so minimum interplanar spacing is lambda by 2. Again, let me say this again, and lambda equal to 2d sine theta is the Bragg's equation. From there, we can derive that sine theta is equal to n lambda by 2d. Sine theta is always less than or equal to 1. So n lambda by 2d is ineffectively less than or equal to 1. So d has to be greater than or equal to lambda by 2. So the minimum interplanar distance d is lambda by 2, where lambda is the wavelength. Okay. So let's move to the last question for today. If an X-ray of 1.54 angstrom wavelength is incident on an atom with angle of incidence 60 degree, what will be the interplanar spacing d for the first order reaction? So you just have to take what is given here. Lambda is 1.54, angle of incidence theta is 60 degrees, and d we need to find. And it says that it's a first order diffraction, so it is a n equal to 1. Again, it's the same equation and lambda equal to 2d sine theta. I'm waiting for some response from your end. Let me discuss it here. So lambda is 1.54 angstrom, n is 1, theta is 60. This is the known data. So n lambda equal to 2d sine theta, or d is equal to n lambda by 2 sine theta. So n lambda will be 1 into 1.54 divided by 2 into sine 60, which is equal to 0.889, which is approximately equal to 0.89 angstrom. So such kinds of questions you can expect for the final exam also. So make sure you know the equation, which is a very basic equation, n lambda equal to 2d sine theta. Please do not expect us to provide the equation prior. Okay, n lambda equal to 2d sine theta. So thank you. That's all for this week's and Tuesday's live session. We will also have a live session on Friday, same timing, 6 to 8. So, in that live session, we'll discuss more about the week 3 and week 4, that is ongoing week's content. So, please be prepared and come. Please watch all the videos and come, so that it will be interesting for you. Otherwise, it will be a first information you are getting from the TAs. So, please watch the videos and come. Okay. So, thank you. And if you have any queries regarding the assignment questions, specifically, you can raise them in the discussion forum. We'll address it there.
Ma'am, can the assignment questions can be discussed in the discuss forum
After the submission,
after the submission?
um, I mean, yeah, we can actually discuss those assignment questions, but I don't know how many of you will prefer that, because some of them are directly asked. Right? As you rightly told, yesterday some questions were discussed and you felt it is repeating. So I thought most of the people will be preferring new questions which are likely to come for the exams, or the type of questions, rather than
So
getting
the
this.
final exams, the questions most probably from this live section and the assignment questions.
No, 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 no. It will be spread not from the live sessions. It will be spread across the assignment questions and fresh questions from the professors, not from the live sessions. So live sessions are just practice sessions where you get to know more questions. See, your database of questions will be more once you prepare for the final exam, if you attend the live sessions also, right? So that is the whole point. You'll get more
The
practice. That's it.
final section will be so much difficult, madam, to pass.
Sorry,
Final
final
year
exam.
exam,
No, 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 no. So the type of questions will be similar to that of assignment questions,
because I am
and
taking it as a coursework.
I understand.
That's
I
why
understand.
I asked.
I understand. I understand. So it will not be very problematic for you because you are going through the assignment questions. If you want us to particularly discuss some assignment questions, let me know through the chat box, because discussing them again in a live session by each of the three TAs, it's just taking up more time
Okay.
unnecessarily. That's just my point. But if you still want us to discuss, we are free to discuss. We can do that, but just mention it in the in the discussion forum, like some particular questions if you want to discuss.
Okay. Thank you, ma'am.
Okay. Yeah. No problem. Thank you, guys. Thanks for being wonderful audience for me. So see you all for next Tuesday's class, and there'll be another class on this coming Friday also. Thank you.